Well, the mount that I designed looks to match the old capacitor, and the mount the board shop built looks to match what I designed. So this kludge might actually work.
Hi, I'm Kevin. Welcome to my cave.
I'm still looking to get this 50-year-old Tektronix oscilloscope back up and running. Last time, I found that it had a bad capacitor in the power supply, and after quite a struggle, I managed to get the supply out of the scope and the capacitor out of the supply. Now I need to choose a replacement for it.
But before I begin, let me offer a quick word of thanks to Danielle van der Bent, Andy Kirkham, Charles Lowmiller, Ray Otwell, John Shepard, and a dozen or so anonymous donors for their contributions to the Get Fed Up campaign at Save the Children. Because of your generosity, we made our goal. Kevin's Cave people are wonderful. Thank you all.
Starting with the basics, the bill of materials shows that it's 14,000 microfarads, with a tolerance of negative 10% to positive 75%. It also needs to fit in the circuit mechanically. The metal can with 4 lugs around the edge of the base all connected to the can, and additional lugs in the middle for the positive terminals used to be a really common form factor for electrolytics, but it's pretty much a thing of the past. I'm going to have to adapt something modern. I need to take some measurements to see what will fit. I started by measuring the board. We'll see why in a little bit. It measures a hair under 5 1/8 inches wide. I'm pretty sure that most things about this scope were measured in fractional inches, because USA. The other end measures pretty much the same. My caliper won't reach the full length of the board, so I'll use a transparent ruler. It's 7 5/8 inches. Better write that down. Now for the can of the capacitor. It's a little bit out of round, but the diameter looks to be 1.5 inches at the base and 1 3/8 inches on the main body of the can. The can proper is about 3 5/8 inches high. But when I measure from where the lug's seated on the board, it's 3 3/4 inches from the board surface to the top. That's too many measurements to be taking at once. Better write them down and double check. Now for that hole pattern. I'll ignore the hole for the big lug at the lower right. It's still all gooped up with solder. I'll take measurements of the 2 outside edges of a pair of holes and the 2 inside edges, and average the 2 to get the center spacing. Of course, I need to go both vertically and horizontally, in case the pattern isn't square. That 5th hole will be a bit of a bear to measure. I think I'm going to go from a photograph. I've put my camera on a tripod with a macro lens looking at the board, because I know that lens has very little barrel distortion. I can get good enough results with a simpler perspective correction of the image. I took several images at different camera settings so that I can choose the best. I'm using a 2-second self-timer on all of them, so that the camera has a chance to settle from the button push and won't get any motion blur. Easier than fishing around in my gadget bag for the remote control.
Before we continue, let me interrupt for a few moments. My videos are always free to all comers. Nothing is ever paywalled, and I don't waste your time selling various dodgy products. But I do end every video with a plea that you take care of one another. To this end, all the channel's ad revenue has gone to charity. This month's featured recipient is Médecins Sans Frontières, Doctors Without Borders. MSF is an independent international organization that offers medical humanitarian aid to people based solely on need, without regard to race, religion, gender, or political affiliation. It provides over 10 million consultations annually in more than 70 countries. including some of the regions most torn by violence, neglect, or catastrophe. And it trains health workers and invests in local infrastructure to meet healthcare needs sustainably in a community-driven way. I'm asking my viewers to join me in supporting this organization. This is a small channel, so I've set a modest goal of $500. Those $500 could provide 2 treatments to cure patients of hepatitis C, 4 resuscitators for non-invasive ventilation in newborns, or enough vaccine to immunize nearly 1,400 children against measles during a deadly outbreak. We managed to meet our goal in the last fundraiser, so I'm sure that my wonderful viewers can get us there again. Won't you please join me today? Thank you so very much.
I put the best of the images up in GIMP, the GNU image manipulation program. It's free and open source. First off, I do a rectangle select and constrain it to an aspect ratio that matches the measured size of the board. I select a rectangle a little bit bigger than the board and crop the image down to that size. Now you can see that the camera wasn't looking quite square onto the board. Next step is to correct that. I select a perspective transform and make sure that I'm doing a backward transformation to correct an image, rather than a forward one to map an image onto an area of a scene. I go to the 4 corners and pull the reference points onto the 4 corners of the board. I zoom in on them and adjust them because this operation needs to be precise. It'll determine the accuracy of our measurements. When I hit transform, the image is squared up, and the resulting image looks pretty well aligned. I'll hit the anchor in the Layers panel to accept the change. Now I'll scale the image to a huge size, exactly 1,000 pixels to the inch. That way I can read out inches directly from the X and Y coordinates at lower left, or use the selection and measurement tools to measure things. I read out the hole locations by hovering the cursor over each of the holes, and sketch the layout in my notebook. It looks as if the outer holes form a 3/4 inch square. Let me sanity check that by making a selection that size. It looks as if it's hitting the hole centers pretty well. A selection half the height confirms that the positive lug is on the center line. I can read out its location with the cursor. Finally, I'll use an ellipse selection to double-check what I measured for the hole diameters. I've sketched the layout in my notebook. I converted the hole sizes to wire gauges and US number drill sizes, since that's almost surely what tech would have used in the 1970s. As a triple check, I made sure that a snippet of 12-gauge solid wire is a close fit in the holes. It feels nice and snug, and the insulation doesn't go in. Now I know what I can use for mounting posts in the holes on the board. Now to pick a capacitor that's both electrically and mechanically right. Get onto DigiKey. You could use Mauser or Farnell or LCSC or whatever's convenient for you. Go to Capacitors, Aluminum Electrolytic, and exclude products that aren't normally stocked and the marketplace products. Now for the capacitor value. The bill of materials calls for 14,000 microfarad minus 10% to plus 75%. If I use a modern capacitor with plus or minus 20% tolerance, I'll have to go a little bigger, probably in the range of 15,000 to 18,000 microfarad. I need a capacitor that's through-hole mounted with radial leads. I don't want the multi-lead snap-in form factors. They'll be a mess to adapt. We know that the 25 volts in the bill of materials can't be right for the filter cap on the 27 volt unregulated supply. I will want at least 50 or 63 volt unit. I like that big a safety margin on my electrolytics, so down select to those. Okay, show me prices in unit quantity. Oh wait, I forgot to specify the size. Separately, I worked through measurements. The existing 1.5" diameter overhung the edge of the board. That's another reason I think it might have been a replacement. So 40 millimeters is going to be a bit too big. 30 millimeters is going to be an inconvenient size because it will put the rim of the can right over the square of the leads. 35mm looks just right. Okay, now looking at the prices, Chemicon isn't a manufacturer I'm familiar with, but I see that Cornell Dubilier is only slightly more expensive, and I know they're good. 26 milliohm ESR and 7 amp ripple current should be way better than I need. Take a peek at the data sheet, and the mounting pattern is the usual modern one. A pair of 2mm holes on 10mm centers. The case is an H9 according to the part number. That's just 2 inches tall, a little over half the height of the old can. Plenty of room below it to adapt to the mounting. Looks good overall. I'll take one of those and add it to my shopping cart. I already have some other odds and ends there, like the 4-input CMOS gate ICs I mentioned baying out of in an earlier video. Tariff on this cap is just 10%. I can live with that. Let's see if Mr. Trump changes it again while the order is being processed. And let's not show any credit card information. Now to design an adapter. In the interest of full disclosure, this is a dramatic reenactment. I got all the way through the board design and discovered that the video from my screen capture was corrupted. If it doesn't look like what you see later in the video, that's why. I hit the schematic editor and set up the paper, including putting in the data in the ID block. I'll place the capacitor on the schematic, give it a value, assign it a footprint. KiCad already has a footprint for a 35mm radial electrolytic with leads on 10mm spacing. Now I'll bounce back and forth between the property sheet and the distributor's website, filling in all the information for manufacturer, product number, supplier, part number, all the annoying details. This isn't terribly important when it's the only part of the project, but it's a very good habit to get into for larger projects, or if you're going to need to send the board out to be fabbed. I'll add the power and ground nets to the capacitor. That will help you with laying out the PCB. And KiCad will want power flags on them to show that the power is coming from somewhere. I'll also put in the 4 holes that will connect the adapter to the power supply board. 2.2mm holes look about right for those. That will be a reasonably close fit on posts made of 12-gauge wire. And that's all there is to the electrical design. I'll quickly run the electrical rules checker to make sure that everything is connected, and then hop over to the PCB editor. Once again, I have to set up the paper. I'll set both the grid origin and drill origin to somewhere conveniently near the center of the page. I'm going to want to position all the mounting holes relative to that origin. Now I need to set up the board properties. I'm not going to bother with all the design rules, because all that I'm going to place is 3 copper fills. I'll just set a 50 thou clearance between them. For the board stack-up, this is a 2-layer board without any SMT components, so I don't need adhesive for solder paste layers. Get rid of those. I'll also get rid of layers for engineering change orders and all the extra user-defined layers. The layer thicknesses are all in place from the last time I ordered a PCB, and they all look right for standard 1.6mm FR4. All I want to specify here is the colors of the solder mask and Silkscreen. And there's no need to spend an arm and a leg on surface finish. Tin lead hassle is fine here. Soldering to lead-free is trickier in the home shop. I don't have to worry about RoHS compliance, and the old scope is full of lead solder anyway. Now for the board outline. I'll go to the edge cuts layer to specify it, and draw a circle 35mm in diameter, so the board will be the same diameter as the capacitor. I'll use the edit function to make it exactly 35. Now I'll import all the footprints from the schematic. I'm going to position them all manually. I'll start with the positive lead. I don't need any Silkscreen labels for the holes. Get rid of those. What I measured in the image was that it was 330 thou from the center. I'll place it there. Oops, I meant 330 thou, not 330 microns. Change the units and try again. Next come the 4 remaining holes. Each of those is 375 thou from the center, both vertically and horizontally. And finally, there's the capacitor. Change the measurement system back to millimeters and place the reference point, which is the positive pin, 5 millimeters to the left of the origin. That looks like the pattern I want. Now to get copper on the board. I'll put fills around the board on both sides and tie them both to the negative 26 volt rail, which is the can of the capacitor. Then I'll put a land in the middle with a 100 thou fillet just because it looks better, that's tied to earth and goes to the positive lead of the capacitor and the positive lead on the oscilloscope board. Give that one a higher priority so that it gets cut out of the negative plane. And fill all the layers. Oops, that doesn't look right. Why is there no gap? Oh, I copied and pasted the plane for the back side of the board, but I never changed the layer on it. Fill again. Much better, a nice gap around the island. Okay, now run the rules checker. Over 400 warnings? Oh, I can't have that solid silkscreen for the capacitor. You can't silkscreen on top of the pads. Let me take that out in the footprint editor. One KiCad trick that a lot of young players don't know is that if you select from left to right, you select only objects that are enclosed in the box. If you select from right to left, you also select objects that are only partially in the box. The fill on the silkscreen is done as hundreds of little lines. I can get rid of most of them with a couple of selections, and then zoom in to clean up the last few, and the drawn outline as well. Remove the Silkscreen C1 label, but it's okay to leave it on the fab layer, and move the component value and the 2 plus signs onto the board. Rules checker again. All that it's yelling about is that I edited the capacitor footprint. I meant to do that. And the 5 mounting posts are under the capacitor body. That's all right. If I need to, I'll cut a shim of plastic to insulate the capacitor body from the posts. Now to dress up the board a little. I'll put my logo on the back side. It took me a while to remember how to do that. The one in my footprint library is on the front, but I got it there. I'll of course label the board with what it is, and put my channel name on the Silkscreen too. And a date so I'll have an idea what notebook to look in if I ever need to remember what I did. Now the rules checker complains about 2 modified footprints, but I meant to do that. I'll put the board shop's order number on the front side under the capacitor, where it won't show when the board is assembled. I'm not showing that just because I forgot to do that in the reenactment. The 3D view looks pretty happy. Let's send it off. Export the Gerbers, and in the Gerber dialog, also generate the drill files in drill map. Make a zip file. And start an order on JLC-PCB. Upload the zip. And the preliminary view looks reasonable. Select the options I want, blue boards instead of grain, leaded hassle finish. Have a look on the site's viewer to make sure the Gerber's transmitted okay. And place the order. It's as easy as that. Then the checkout is just the same as any other web store. I'll not go to the next screen here because you don't need to see my credit card details. They gave me a 2-day estimate for production, and then I've asked for their standard shipping.
So now I need to wait for both the capacitor and the boards to arrive. Future Kevin here. I planned to cut the episode off here, waiting for the shipping. But the orders arrived lickety-split before I got done with post-production on this video.
I found on my porch a mailing pouch with a neat little blue box inside. And well packed inside it, a little plastic bag with PCBs inside that. Let's take a closer look. The Silkscreen is wonderfully clear. I had worried a bit about whether my logo would reproduce, but I'm happy with it. Both sides of the board look equally nice. The holes in the board fit perfectly over the mounting holes in the old board. I did a quick dry fit with the capacitor, which arrived the same day, and one mounting post cut from 12-gauge wire, and everything fits nicely. I think this is going to look like a pretty clean job.
Next time, I'll solder up the adapter, fit it to the scope, and try to get things cleaned up and put back together to find out what else might be broken. See you then. Perhaps you might want to tell YouTube that you liked this video and want to see more like it. Until next time, stay safe, stay healthy, stay curious, and take care of one another. Bye.